Good afternoon. Only one JNB here, JNB Tahoe. Good afternoon, everyone. So, today in the class, let's not wait further because it has been already 2 minutes past 3 o'clock, I guess. Yeah. So, we should start ideally. Chalo. Rest people will join gradually, I guess. Okay, let's wait for others than 1 minute. For 1 minute, I can wait. And how is everybody? How is your classes going on? How is everything? Are you all good? It's very important in this weather that you take care of your health, everything. Take food on time. Don't escape any meal. Take care of your health because if you won't be healthy, you won't be able to work, है ना? That is very important. So everyone, just stay cautious of your health. So now let's get started. Here, 3 JNBs, no, 2 JNBs, 1 Dhanasri. Okay, done. वेट करने लगूंगी तो पता चला सारे ही आधा क्लास का टाइम तो ऐसे ही चला गया just in waiting. So there's no point of waiting anymore. So what we are going to read in today's class, yeah, JNB Tahoe. आज के क्लास में हम क्या पढ़ने जा रहे हैं? So from the topic itself, it's very clear कि we are going to talk about magnetism, है ना? But which portion of magnetism? We will be in today's class basically doing questions from moving charges in magnetic field. Then you already must have studied charges in magnetic field thing in your CBSE class, right? So today, before moving on to the question, I will give you a brief overview of which concepts will be useful in solving the question. Okay? So for first 10 minutes, we will go through what? We will go through theory, and after that, we will be doing questions. Chalo. So motion of charged particle in a magnetic field. You all must have studied that if there is a charge, done and it is kept in a magnetic field, suppose from this cross symbol you all must be aware of. This is a symbol of inward magnetic field. Inward magnetic field means magnetic field which is into the plane of paper, and dot denotes what magnetic field out of the plane of paper, right? So I have taken here a charge particle which is kept in an inward magnetic field. So what was the observation? Observation was that if velocity of charge particle is zero, force acting because of magnetic field was zero, right? And if velocity was parallel to magnetic field, in that case also magnetic force was zero. Yani ki even if it has some velocity, but if velocity is parallel to magnetic field, magnetic force is zero. कुछ ऐसा observation आया था, है ना? And if you're going to write the formula for magnetic force acting on a charged particle that is basically moving in magnetic field, then it will be equal to QV cross P. Now, what are the important things that we should keep in our head while applying this formula? Very first thing is that this Q thing, if this Q thing is positive, then no issues. But if this Q thing is negative, just say if you're talking about negatively charged particles such as electron, then whatever direction you are getting from V cross B, direction of force will be negative of them. So how we will calculate the direction of V cross P? Again, we will go on to the vector. Vector आप सबने पढ़ा होगा. So in vector, suppose कर लो here in this case, my charge particle is moving in this direction. ठीक है? So if this direction I have taken as x-axis, this direction I have taken as y-axis, and direction perpendicular to the plane is taken as k or minus k cap. That is into the plane minus k cap, out of the plane plus k cap, right? So velocity is in which direction here? Velocity is in I cap direction. Magnetic field is in which direction here? That is into the plane of paper, yani ki minus k cap. So direction of force will be in the direction of V cross B, that is in the direction of I cross minus K cap. So if you're going to calculate the direction, what it will come to be, it will come to be like we can do that through this method, है ना. वेक्टर में हमने पढ़ा है कि I cross J is equal to K, K cross I is equal to J. So if you are moving in clockwise direction, we will give positive signs. If we are moving in anti-clockwise direction, that is, if I am going to find out I cross K. So I cross K निकालने का मतलब क्या हुआ? I cross K निकालने का मतलब ये हुआ कि I am going in anti-clockwise direction. So I cross K will be minus J. So I hope you people are clear with this thing, right? ये जानना बहुत जरूरी है. Throughout magnetism, it will be of use help. Sorry. It will be of use help, right? So this is very much basic, but it should be in your head, right? So I cross minus K, यहाँ से देख लो, I cross K का वैल्यू क्या होने वाला है? Minus J, and already minus sign है, so it will be J. So if somebody asks you कि यहाँ पे जो चार्ज है, इस पे फोर्स का मैग्नीट्यूड क्या है? So that you will tell QVB, right? क्योंकि यहाँ पे angle between velocity and magnetic field is what? 90 degree. But what is the direction? So direction you will find out like this, and here it is J cap direction. Done. So एक चीज मैंने क्लियर किया कि how you will find out the direction of magnetic force acting on a charged particle. Second thing which is very much important is determining the trajectories of the charged particles moving in magnetic field. जैसे if I take the example of previous case only, so in previous case my magnetic field was like this. अब देखो यहाँ पे whatever vacant space is here, जैसे ये वाला space vacant है, it doesn't mean कि यहाँ पे magnetic field नहीं है. It also has magnetic field of same magnitude. ठीक है, हर जगह मैं cross नहीं draw कर सकती ना, that is why. Done. So यहाँ पे अब आप देखो एक Q charge है आपके पास, and this Q charge is moving in this direction. Again, just now we have calculated force acting on this magnetic field will be in which direction? Direction will be parallel to what? J cap. So force is going to act in J cap direction. But how this particle will move? Will it go in a straight line along the y-axis because force is acting along y-axis? Will it go undeviated in the straight path, or what will be the trajectory? Done. So trajectory you all must have studied circular motion, है ना? पढ़ा है ना circular motion? So in circular motion you all must be aware of if particle is moving in a circular motion, it means if you see this particle is suppose moving in circular motion, so its velocity is tangential to the trajectory, and at the same time it has net force acting towards the center. So direction of force and direction of velocity are what? Are perpendicular to each other in circular motion. If you talk about centripetal force, then centripetal force is what? Perpendicular to the velocity, है ना? कुछ ऐसा है. And here if you see carefully, magnetic force is what? Magnetic force is Q V cross V. So definitely this force is cross product of V and V. So F will be perpendicular to both V and B. So finally, magnetic force is perpendicular to the velocity. It means because of this force, this particle will go in a circle. Then the trajectory is clear, it will go in a circle. But the next task is, where will be the center of circle? What will be the radius of circle? Chalo, radius of circle you will easily calculate by equating force to centripetal force value, that is mv square by r. But how to draw the center of the circle, that is most important thing I assume. तो यहाँ पे देखो कैसे निकालेंगे, मैंने बताया था कि फोर्स का डायरेक्शन इज पैरेलल टू व्हाट? जे. तो जस्ट यहाँ पे मैग्नेटिक फील्ड स्टार्ट हो रहा है, सपोज कर लो. सो हियर चार्ज पार्टिकल इज एंटरिंग एंड व्हाट इज हैपनिंग हियर? Force is acting on the charged particle in which direction? In J cap direction. So यहाँ पे force act. So here force is acting towards this point. And I have said you this particle will go in a circle. Circle में जा रहा है, इसका मतलब क्या? Force will act towards the center. So center must be somewhere along the J axis. So now close your eyes and just get one thing clear. If you have to draw the trajectory of charged particle, first thing what you need to do is you need to determine what will be the direction of force. Done. Okay. Someone trying to speak out. Okay, done. So what I forgot actually. Okay, so first thing you need to do is you need to find out in which direction force will act. Along that direction only center will lie. So जहाँ पे एंटर किया है वहां पे ही उस डायरेक्शन के along एक डॉट बना लो and treat this dot as a center. So if this is center, it will go on like this something, है ना? So this will be the trajectory. Determining trajectory is very important. Now let's go on to the value of radius. So how we will calculate the value of radius? Very simple. Magnetic force value is QVB sine theta, क्योंकि V cross V it is. And since this is going in a circle, this is acting as a centripetal force. It will be equal to mv square by r. So here radius will be equal to what? QVB sine theta by mv square. So one v will get cancelled. You will get as sorry, मैंने ऑपोजिट लिख दिया. आर को क्या लिखोगे? आर को लिखोगे, चलो एक बी को कैंसिल ही कर लेते हैं. यहाँ से एक बी कैंसिल होगा, यहाँ पे एक बी बचेगा. सो आर विल बी इक्वल टू एम बी बाई क्यू बी साइन थीटा. एंड इफ थीटा इज 90 डिग्री, radius will become equal to what? mb by qb. So if you know the radius of circle, you can calculate time period. Time period क्या होगा? 2 pi r by v. So simply put the value and get the answer. So 2 pi radius का value क्या है? mv by qb divided by v. So v will get cancelled and time period will be 2 pi m by qb. So basic thing is कि time period will be independent of velocity and all. So this is time period. Frequency you can calculate 1 by t, right? So these are all things. One important thing here is कि many places you will get a question like what will be the work done by magnetic force here. So work done का formula क्या होता है? If you remember carefully, it will be F dot ds, है ना? And here force acting is what? Q V cross V, something like that. Dot ds करोगे आप, करोगे ना? हाँ, अगर मैं यहाँ पे देखो पावर डिलीवर्ड की अगर मैं बात कर दूं तो डी डब्ल्यू बाई डी टी मैं करूंगी तो यहाँ ds बाई डी टी हो जाएगा. यू जस्ट सी हियर क्यू वी क्रॉस बी डॉट बी डॉट वी है ना? So V cross B is perpendicular to V and its dot product with V will be what? 0. So no power is getting delivered by magnetic force. It means magnetic force is not doing any work. So work done by magnetic force is going to be what? 0. Power delivered by magnetic force is going to be what? 0. So these are the things you need to remember while solving question. Okay. So आज का question is totally centered around this, and this is a huge topic actually. If you will go into previous year question, you will encounter lots of questions from this portion. Okay, so let's first now मुझे this is not a question, particular question, but यहाँ पे I want you all to try doing one thing कि आप trajectory बनाओ. How electron this is a positive charge particle, suppose how that will go inside this field region and then inside this field region. सभी लोग अपनी कॉपी पे ट्राई करो. This is very important. Okay, do it now. Because this topic I also dealt with, I told you how to find it out. So you can do that very easily. Even if you have not studied it before, you can crack it now. ठीक है, तो करके बताओ. सबका आना चाहिए. मैं इधर ही हूँ, don't worry. You can ask with me doubts like if you're not able to understand, you can text me as well. Okay. Are you all able to understand? So many Gen Bs are absent. So many. Chalo, come on. How many of you did it already? How to find it out? Just imagine charge is entering here. Just calculate force direction at this point. Just calculate force direction at this point. Suppose, let's say it point A. Okay? Just tell me in the chat box what will be the direction of force here. Let me draw this. I have drawn this. So now you can go use. Yes, I'm waiting for the direction of force when it is entering at the point A. Let me know in the chat section, both here and on also YouTube. Come on here. You people are not taking effort, I guess. And this should not happen here. This should not happen. You simply need to tell me what will be the direction of force. Chalo, I'm not going to move ahead if you're not going to give me the answer. Got it now. Sorry, get it now. I'm not going to move ahead. I'm telling you. I'm very stubborn. Because if you're not able to tell me the direction of force here, what is the point of doing questions ahead? It will be wholly, totally useless. Like I will be crying here at the top of my voice and you people will be just. So you people have not studied magnetism in your school? JNP Tahoe. सारे लोग मुझे बताओ. Did you study magnetism in your CBSE class? My question. Have you been taught this chapter? According to whatever timetable is given, according to that, it's done already. देखो कोई जवाब ही नहीं देता. My dear, you just need to tell me here the direction of force. Formula of force is what? Dekho, I never give up while explaining. I'm telling you. Even if you're asking me 1,000 times, I will be telling you 1,000 times. But the thing is, we should have time for those 1,000 times. That's the problem. We have so much sort of time. And at the same time, if you people are not coming prepared, in the last session only, I told you in the next class, I will be going on with magnetism. So at least you should have gone through formulas. Yeah, this is really disappointing. So what's the formula of force? It is QV cross B, right? QV cross B. So just see what is the direction of velocity here. What is the direction of velocity here? Direction of velocity is I cap. So this charged particle is moving in the direction I cap, है ना? ये चार्ज कैसे जा रहा है? इसकी वेलोसिटी इधर है ना? इस डायरेक्शन को हम लोग क्या मानते हैं? X axis. So by convention, by default, this is x-axis, this is y-axis, and whatever is perpendicular to it is taken as z-axis, right? So that is x, y, z. Here, from the diagram, it is clear that charge is moving in plus x direction. It means direction of velocity is what? I cap. Direction of magnetic field is what? This is inward magnetic field. This is inward magnetic field. देखो, out of just concern I'm asking, सभी लोग मुझे reply दो please. I just want to know. क्या तुम लोगों के सीबीएसई क्लास में ये चैप्टर हो चुका है? Just let me know यार. I don't want to waste just time by telling you something that you're not able to get. So just tell me, is it done in your CBSE classes? If you can't type, just do one thing. जिनके क्लास में हो चुका है, you raise your hand. नहीं हुआ? Okay. Others, please. ठीक है, but one thing I'm telling you, you don't need to worry about. अगर नहीं भी हुआ है तो don't worry. I told you already कि आज के क्लास में क्वेश्चन किस बेसिस पे होगा. So whole thing is force equal to q v cross p. Force acting on a charged particle, moving charged particle. How you will calculate the direction? By simply using vectors, that is cross product. So cross product of velocity and magnetic field. Velocity here is in I cap direction. Magnetic field here is in which direction? K direction, K cap. So I cross K cap किसके बराबर होगा? अब ये बताओ मुझे. अच्छा, जेनवी खोबाई सबके स्कूल्स में नहीं हुआ है, बट शेड्यूल आई सॉ उसमें लिखा हुआ है कि अभी तक ये चैप्टर स्कूल में हो गया. It is written over there, right? That is why we are taking up these chapters. Okay, लेकिन नहीं हुआ है तो डोंट वरी, क्योंकि मैं क्लास में थोड़ा रिव्यू दे देती हूँ, उसके बाद ही क्वेश्चन पे जाती हूँ. So let's now go through it. अब मुझे बताओ डायरेक्शन ऑफ फोर्स will be what? Just let me know first. In the first case, I cross K will be equal to what? Vectors you already must have studied in class 11th, right? So I cross K किसके बराबर होगा? I cross K is equal to what? Minus J, because we are going in anti-clockwise direction, right? So I cross K is equal to minus J, यानी कि force will act in minus J direction. तो minus J का मतलब चालू कर रहा है. Join this up. यार है muted everybody. तुम्ही बताओ ना कोणता आहे? क्या घेतली? पार्पल सीरीज करने का. Okay, done. I cross K, done. So I cross K is minus J. Minus J means what? At this point it is entering, right? So at this point this is x-axis and this is y-axis, done. So force is acting along minus y-axis. It means where force will act? Force will act somewhere in this direction, है ना? Force will act in this direction then. तो center इसी direction में कहीं पे ले लो. So here I am taking the center of circle. So my charge particle will go in a circle जिसका center इधर है, तो कुछ ऐसे जाएगा, ठीक है? ऐसे. अगर ये यहाँ तक आया, यहाँ पे again it will encounter some different magnetic field. That is in which direction? Again that is in minus K cap direction. So here force will act in a quite different way, है ना? Not like this. But before that, let me again take you through the whole revision. So मैंने क्या क्या पढ़ाया अभी तक? मैंने ये बताया कि if there is a charge moving in a magnetic field, force will act on it, and force value will be what? Q V cross V, where V is the velocity, V is the magnetic field. How we will calculate the direction of magnetic field? By using V cross V. Done. So just do the cross product. Cross product कैसे निकालते हैं? This is the circle IKJ, right? IJK. So if you are moving in clockwise direction, you will get positive sign. If you are moving in anti-clockwise direction, you will give negative sign. So I cross J will be equal to K cap, I cross j k cap, k cross I will be equal to j cap, and likewise अगर आप opposite में जाते हो, I cross k if you're going to do, then I cross k will be equal to minus j, and k cross j will be equal to what? K cross j will be equal to minus I, like that. बस ये चीजें तुम्हें सिंपल करनी है और कुछ नहीं करना. Done. With direction you have to do this only. Now about magnitude, like यहाँ पे तो direction discuss किया था मैंने. So if you have to calculate की what will be the radius of that circle in which it will go, then radius we can simply calculate by equating force to the centripetal force. Centripetal force formula, that is mv square by r. So r is what? mv by q. Time period we can calculate, that is 2 pi r by v. So यहाँ पे simply I put the value of radius, that is mv by qb. So 2 pi r by v, क्योंकि time period यही होता है ना. This is circle. If something is going round in a circle, time period means how much time it will take to go completely in a circle. So complete circle का मतलब how much distance it is going, 2 pi r, है ना? With how much velocity v, so how much time it will take, distance by velocity, so time period is this. Okay, so this is the time period. Time period value we got as 2 pi m by q, right? So this is this. Then next I said ki work done by magnetic force will be what? So magnetic force वर्क डन क्या लिखते हैं हम लोग? एफ डॉट डी एस लिखते हैं. मैंने क्या किया? पावर निकालने की कोशिश किया. सो रेट ऑफ वर्क डन, दैट इज फोर्स के फॉर्मूला को लिख दिया, क्यू वी क्रॉस वी डॉट डी एस बाई डी टी, राइट? So now this V cross B, you already have studied cross product in class 11th. If C equal to A cross B, it means C is perpendicular to A and also C vector is perpendicular to B. It means here also, if V cross B we are talking about, so whatever is the resultant of V cross B, that is force. So force will be perpendicular to V also and force will be perpendicular to B also. So if force, if this is perpendicular to velocity, if this is perpendicular to velocity and we are doing F dot V, then F is what? Perpendicular to velocity. It means the angle between F and V, angle between this term and velocity is 90 degree. So their dot product is going to be 0. क्योंकि dot product का formula is what? A dot B is equal to what? It is mod A mod B cos theta. And if theta is 90 degree, cos 90 will become equal to 0. I hope you all know basic of vector. Because if you don't know basic of vector, you can't understand magnetism. Again, I'm telling you, कल के क्लास के लिए प्लीज गो एंड रिवाइज वेक्टर्स का क्रॉस प्रोडक्ट एंड डॉट प्रोडक्ट. ठीक है, डू दैट. चलो, अब ये क्वेश्चन को तुम्हें कुछ भी नहीं करना. प्लीज डोंट साई अवे फ्रॉम डूइंग क्वेश्चंस. ऐसा मत सोचो कि इन स्कूल इट हैज नॉट बीन टॉट, वी कांट डू द क्वेश्चन. व्हाटएवर आई हैव टॉट जस्ट नाउ, बेस्ड ऑन दैट यू कैन डू द क्वेश्चन. सो टेक योर 2 minutes एंड डू दिस क्वेश्चन. हाँ, मैंने एक बार और एक्सप्लेन कर दिया है ना. आई होप आई हैव आंसर्ड यू. इफ नॉट तो तुम कमेंट कर सकती हो, ठीक है, बता सकते हो मुझे. चलो प्लीज यार, आई एम टेकिंग एफर्ट, यू शुड आल्सो टेक एफर्ट. मुझे आंसर नहीं चाहिए, मुझे चाहिए कि यू पीपल आर जस्ट रीडिंग द क्वेश्चन एंड ट्राइंग टू डू. आई नीड दैट. Even if you are not reaching up to the answer, it's okay for me. What I want is, I want you all to solve it. Read the question first and then try solve it. can be the whole. Okay. आपका आंसर जस्ट ऑपोजिट आ रहा है गेस. ध्यान से देखो, प्रोटॉन इज रिलीज्ड. क्वेश्चन क्या है? क्वेश्चन को ध्यान से तुम लोग पढ़ो. सबसे पहले मैं फर्स्ट पोर्शन पढ़ती हूँ, ठीक है. When a proton is released from rest in a room, so there is a room, और इस रूम में एक प्रोटॉन है, चेन बी डाहो. मैंने बोला ना आपका आंसर जस्ट ऑपोजिट है. तो ईस्ट का ऑपोजिट क्या होगा? दोनों का ऑपोजिट. ठीक है. तो यहाँ पे एक रूम में एक प्रोटॉन है हमारे पास जो कि रेस्ट में था. ठीक है, रेस्ट में हमने रख दिया एंड इट इज उस रूम में जाने के बाद इट स्टार्ट्स with an initial acceleration of a naught towards west. It starts moving towards west. So it started moving towards west. ठीक है. Now when it is projected towards north with its speed v naught, second time क्या हो रहा है? There are two different cases given. ठीक है. Second time what is happening? स्नेहा नहीं हुआ, कोई चाप नहीं. So second time what we are doing, we are letting it go in the north direction. ठीक है, with its speed v naught. And second time what is happening? It moves with an initial acceleration of 3a naught towards west. This time it is moving in this direction with velocity 3a naught. ठीक है, done. So what is question? Electric and magnetic field in the room H. अब आप ध्यान से देखो यहाँ पे इस केस में क्या हुआ. इन फर्स्ट केस व्हाट वाज हैपनिंग? सो इट स्टार्ट्स विद यहाँ पे रेस्ट पे रखा हुआ था. ठीक है, इट इज इन रेस्ट एंड इट स्टार्ट्स मूविंग टुवर्ड्स वेस्ट. पूर्णिमा, यस, इट स्टार्ट्स मूविंग टुवर्ड्स व्हाट? वेस्ट. इसका मतलब क्या हुआ होगा? On this charged particle, what is happening? Some force must be acting towards west, है ना? And in the first statement, if you focus on the first statement, in the first statement, it is not given that it is moving in a circle or something like that, है ना? Clear है? So it was in rest. Initial velocity was 0. The moment we are keeping it here, and if its velocity is 0 initially, what will happen? Magnetic force will not act. No, if v is 0, magnetic force will not act. So here, if from v equal to 0, it starts moving towards west, it means magnetic force is not acting, some other force is acting, and that can be electric force. So electric field must be in the west direction, right? क्योंकि इलेक्ट्रिक फील्ड जो है वो फोर्स किधर लगाता है? पॉजिटिव चार्ज टुवर्ड्स इस फील्ड डायरेक्शन. So electric field must be towards the west direction. How much should be the value? Acceleration is a naught here, so you can write a naught into m equal to q into electric field. प्रोटॉन का चार्ज कितना होगा? इलेक्ट्रॉन के चार्ज के बराबर होगा, है ना? So electric field value will be ma naught by e. Electric field value is how much? Sorry, ma naught by that is your e, small e, right? So this is the electric field. Now come to the second case. In second case, what is happening? In second case, we have given it velocity towards north, and at that point of time, it started moving towards which direction? Instantaneous acceleration it is talking about. So it started moving towards west. It means what is happening? It means obviously it is in this room only. It is in this room only. So it's the same room it is talking about. Na? So if here there was an electric field of this much magnitude, here also electric field of this much magnitude should be there in this direction. So if we are projecting charge particle towards north with velocity v naught, electric force will act even though. So electric force का value सबसे पहले लिख लो, वो कितना होगा? इलेक्ट्रिक फोर्स का वैल्यू लिख लो, एक सेकंड. सो इलेक्ट्रिक फील्ड force acting will be equal to how much? It will be equal to q into e, and electric field value you already know, ma naught by e. So this is basically ma naught. So acceleration because of what? Electric force will be how much? A naught, just as before. So it has net acceleration of 3a naught. It means raised to a naught acceleration must be because of which force? Magnetic force. Done. अब आप एक काम करो, मैग्नेटिक फोर्स का फॉर्मूला लिखो, Q V क्रॉस B. So velocity and magnetic field may have been perpendicular here because nothing is given about the direction. So यहाँ पे perpendicular लेकर चलते, Q V B will be equal to how much? Mass into acceleration, that is 2a naught. ठीक है. So Q का value is how much? E. Now, if you calculate the magnitude of magnetic field, it will be equal to how much? 2ma naught by ev naught. Okay? And in which direction it will be again? We need to check the direction. अब यहाँ पे देख लो, magnetic velocity direction is where? मैग्नेटिक फोर्स का अगर डायरेक्शन चेंज चेक करना है तो एफ बी को आप लिख लो, दिस इज क्यू वी क्रॉस बी, राइट. सो जस्ट ट्राई टू सी which is the direction of velocity. Velocity was given in towards north. तो north को हम लोग क्या कह सकते हैं? Y axis. east को क्या कहेंगे? Plus x axis. west को कहेंगे minus x axis, right? And this is minus y axis. Done. Downward direction will be taken as what? Minus k cap. Upward direction will be taken as plus k cap, right? तो यहाँ पे velocity का direction क्या दिया हुआ है in the question? It is j cap. And force का direction is towards what? Force का acceleration I said because of magnetic field is 2a not towards west. So force is in towards west, that is minus I cap. यानी कि force direction is minus I cap. So what will be the direction of magnetic field? Again go to that trajectory, I j k वाले term में चले जाओ. So this is j. J cross what will be minus I cap. So j cross k. J cross k will be I. So j cross minus k will be minus I. यानी कि magnetic field should be equal to should have a direction of minus k. Minus k means downward. ठीक है. So magnetic field should be downward, having magnitude 2m a naught by ev naught. So this one. And electric field value should be how much? ma naught by e towards west, right? So this is that. Clear for everyone? I explained this much because some of you have not studied. That is why. Let me know, is it clear? Is it clear? Anyone having any doubt? First time, what was given? Velocity was 0 and force was acting towards space. So if velocity is 0, no magnetic force will act, right? So definitely electric force will act, and that electric force value will be like this. You will write the acceleration given is a naught. Second time, total acceleration in the west direction is 3a naught. So a naught acceleration is because of electric field. Raised to a naught must be because of what? Magnetic field, no doubt, right? Chalo. Now let me know answer of this question. Again, take some time, 2-minute time, and try doing it. You just need to do with the direction, nothing else. Just Q B cross B formula will give you the answer. This B cross B direction thing will give you the answer. So you just need to go with it. Do it now. You can easily do it. I'm telling you, don't need to worry about कि ये सब क्या दिया हुआ है. Just try to see the diagram carefully. मैं एक बार समझा भी देती हूँ. जैसे देखो यहाँ पे एक चार्ज पार्टिकल है जो कि पॉजिटिवली चार्ज पार्टिकल है. It is coming like this, like this. जैसे ही it is coming here, what is happening? It is going on like this. And this trajectory is not exactly circular, it is saying, but it is curved now. So if it is curved, it will have center somewhere. Small arcs will have center somewhere. And अगर तुम्हें trajectory सही से दिख रहा है, अगर if something is going like this, then for a small arc, center will be somewhere here, है ना? Then so center is somewhere here. It means what? Magnetic force must be acting at this point in this direction, है ना? कोई भी एक पॉइंट पे चेक कर लो, जैसे इस P पॉइंट पे velocity is in which direction? P पॉइंट पे velocity is in which direction? Charge particle was moving in this direction. Done. So velocity का direction तुम चुपचाप लिख लो, that is I cap. Done. Now just by looking at the trajectory, try to know कि at point P magnetic force will act in which direction. So at point P its trajectory has curved like this. अगर ये इधर की तरफ कर्व होता तो center at point P force must be acting somewhere in this direction. But if it is curving downward, it means force is acting somewhere here in this direction, right? So if force is in minus j cap direction, है ना, force का direction मिल गया minus j cap. So magnetic field direction surely should be in which sense? Just try to find that out. You will get the answer. Let me know if you're getting. Yes. Yes, let me know if any one of you has got the answer. चेक कर लो, एक काम करो, यहाँ पे B का वैल्यू है ना, जैसे जस्ट ट्राई टू चेक इट. डायरेक्शन कैसे चेक करते हैं हम लोग फोर्स का? आई टोल्ड यू ना, फोर्स इज व्हाट? Q V cross V. Whenever you are getting confused with the direction, just draw this वाला thing. इसको ड्रॉ कर लो, ऐसे लाइंस बना लो, ठीक है? So what is happening here? Velocity is in I cap direction, force is in minus j cap direction. So I cross what will be equal to minus j cap. So I cross j is k. I cross like resultant we need as minus j ना. So I cross k क्या होगा? I cross k अगर जाओ तो I cross k will be minus j, है ना? I cross k will be minus j. You can see from here clearly, right? So यहाँ पे if force is acting towards negative y axis, it means कि magnetic field should have a direction along k axis for sure, है ना? So यहाँ पे जो भी terms है, यहाँ पे जो भी magnetic field का terms है in the option, try to see where magnetic field is in k cap direction. तो आपको दिख रहा होगा सभी में है. जैसे फर्स्ट ऑप्शन में अगर देखो तो मैग्नेटिक फील्ड इज इन j cap and k cap direction. Here magnetic field is in k cap and I cap. Here it is in j cap and k cap. Here it is in k cap and j cap. ठीक है, तो k cap में तो श्योर होगा. How to filter the rest? कैसे फिल्टर करें? तो यहाँ पे ध्यान से देखो, if magnetic field is suppose j direction, also in j direction, तो I cross j क्या हो जाएगा? k. जैसे फर्स्ट ऑप्शन को अगर मैं लेकर चलूं तो magnetic field here is of magnitude b in j cap direction, and if magnetic field is in j cap direction, force acting will be in which direction also? और किस किस direction में magnetic force लगेगा? तो v cross b करोगे, velocity is always in I cap direction at point P, right? So I cross, what you will do? I cross j will give you k cap. So force will be k cap in the k cap direction. So force should be both in minus j cap and k cap according to first option. But at this point, can you see that this circle, this arc has center somewhere on the k axis? नहीं ना, क्योंकि this arc is basically in xy plane. It can't have a center on k axis, right? It can't have a center on k axis. Done. So this can't be true. And if you come here, one force is in k cap direction, one magnetic field is in k cap direction. वो तो correct है, हमने अभी भी check किया. And another magnetic field has a magnitude of A in I cap direction. And if magnetic field is in I cap direction, it will have no effect on its trajectory. क्यों? क्योंकि force को क्या लिखते हो? V cross V. Velocity is in I cap direction. Magnetic field is in I cap direction. I cross I 0. Done. So this may be correct. This can be correct now. क्योंकि if magnetic field is in C K cap plus A I cap direction, net magnetic force will still act only towards minus J direction, because magnetic force because of magnetic field in X direction will be 0. So this will be correct answer. Rest में देखो यहाँ पे भी magnetic field J direction में है, और अगर magnetic field J direction में है तो तुम्हारा magnetic force कहाँ लगेगा? K cap की तरफ लगेगा, which is not clear from the diagram. Which is not true from the diagram. From the diagram, it is clear that magnetic force is acting at point P towards negative J axis. Sorry, negative Y axis. That is minus J cap. So correct answer should be what? P. I hope you people are getting it. Is it clear? You just needed to see the magnetic field can't be in J cap direction. Simple. And in all the other option A, C, D, if you see carefully, magnetic field has a component along J cap direction, which can't be true according to the diagram given. Is it clear, everyone? क्या हुआ सभी इतने शांत हो? Is it clear? Because I'm taking so much effort to explain things, just assuming you have not studied it. But you know, one thing I just want to tell you right now, you can't give excuse in your examination hall to yourself कि हमारे टीचर ने हमें पढ़ाया नहीं. तुम्हें पता है वो excuse का कोई मतलब ही नहीं है, because you are sitting in an exam hall. Even if your teacher has not taught you, they are not going to suffer. I am telling you, they are not going to suffer. है ना? Actually उनको पढ़ाना चाहिए था, but उन्होंने नहीं पढ़ाया. It may be their fault, but who is going to suffer? Question is that here. Suffer कौन करेगा? तुम करोगे. So who should look out for the solution? You. है ना? अगर तुम्हें चीजें नहीं पढ़ाई गई है, just there's so many ways you can learn things. है ना? In schools you have access to tabs, something, somewhere. है ना? So you can just go through some of the lectures. You can try to learn, क्योंकि this should be your task. मेरे पास जितना वक्त है, I will be doing that, but effort should come from your side also. That was only my motto. चलो इस क्वेश्चन को मुझे करके बताओ क्या होगा. Just read the question. Don't stress out. Stress लेने की जरूरत नहीं है. Stress से कुछ भी हासिल नहीं हो. Just read the question and try to understand. Nothing you need to do. Basic mechanics you need to apply, and that I have discussed already in the class just now. तो क्वेश्चन को ध्यान से पढ़ो और बताओ क्या होगा. You all are aware of MEV, mega electron volt? Because I have also explained that while teaching you electrostat. I remember what is the meaning of electron volt. I have discussed that in the class. I hope some of you will get the answer. Yes, very good. Thank you so much, Genvi Dahod. Yes, thank you. It's really a relief, yeah. Some answers are coming. I'm thankful. Chalo, let's other people please come in and let me know what you're getting. YouTube वाले बिल्कुल शांत बैठे हैं, क्या हो गया? Let me know the answers, please. I hope you all are understanding. Asika, Ankita, Dhanashri, JNV, Ahmednagar, Anand, Bhavnagar, Shimoga वाले तो गायब ही हो गए और सारे लोग चुप चुप बैठे हैं and some JNVs didn't join. One out of them is JNV Yavatmal. It's not here. ठीक है, चलो मैं ही बताती हूँ, है ना. A proton and an alpha particle both enter region of uniform magnetic field B, moving at right angle to the field. यानी कि velocity is perpendicular to the field it is given. If the radius of circular orbit for both the particle is equal, V is perpendicular to B. Radius का formula क्या होगा? mv by qb. And their radiuses are equal. And the kinetic energy acquired by proton is 1 MeV. Energy acquired by the alpha particle will be what? So their radius are equal. First thing. अब radius अगर equal है तो कैसे क्या लिखोगे? Radius of proton is equal to radius of alpha particle. Radius of proton को क्या लिखोगे? Mass of proton, velocity of proton divided by charge of proton into magnetic field will remain the same for both. M alpha V alpha by Q alpha V. B को cancel कर दो. अब देखो एक चीज ध्यान से देखो, mass of proton and mass of alpha particle is related as what? Mass of alpha particle is 4 times mass of proton. And also charge of alpha particle is 2 times charge of proton, है ना? So we are going to put it like that. अब यहाँ पे अगर ऐसे put करोगे तो MP, VP, QP will be equal to what? 4 mass of proton into V alpha divided by 2 charge of proton into what? Into nothing. Done. This is all. So 2 QP को cancel कर दो, इसको cancel कर दो. So velocity of proton is what? 2 times velocity of alpha particle. This is what we are getting. And in the question, it is given that energy of proton is 1 MeV. So what will be the energy of alpha particle? If you're going to write the energy of alpha particle, you will write half mass of alpha particle, velocity of alpha particle का square, right? So half into mass of alpha particle क्या लिखोगे? 2 into mass of proton into velocity of alpha particle को क्या लिखोगे? Velocity of proton by 2 का square. So you are going to get what? This will become how much? So this is half. I hope I have not done mistake anywhere. So velocity of alpha particle, that is velocity of proton by 2. JNV Bhavnagar. No, that's not true. So half into what you are going to do? 2 into mass of proton into Vp ka square by 4. Done. Sorry, mass of alpha particle will be 4 times mass of proton. Done. So here it will be 4. 4 will get cancelled and you will get as half mass of proton, velocity of proton ka square. So both are equal. Energy of alpha particle is equal to energy of what? Proton. Done. So correct answer will be B. So we are running out of time now. So this would close here. But one thing I want to tell you, for tomorrow's class, please come prepared. I will be doing or we will be doing question from the same person what I taught today. So please do revise and after that come into the class. It will be a great favor. Okay. Both upon me and also more on yourself. So अपने आप पे favor करो और कल पढ़ के आना. ठीक है? So everyone take care of yourself. Bye-bye. I'm not going to give you homework and any question as a homework, but your homework is to revise through topics. Okay. What is the topic? Moving charge in a magnetic field. And that you will be going. Okay. So please करके आना. चलो. Bye-bye. Take care. Everyone stay safe, stay happy and enjoy. Okay. Thank you so much. Thank you. Thank you. Bye-bye.